Hello, Cooler Company. My name is Mandeep Patel. I'm a mechanical engineer at the University of Texas, and this is my design for an environmentally friendly cooler. This design does not use traditional materials, and in fact, the whole goal of this design was to reduce the total amount of material required. This is done by excluding traditional materials such as EPS and styrofoam. They just aren't biodegradable, and their biodegradable counterparts are either already patented or they create byproducts in the manufacturing process which are just not environmentally friendly. This design reduces the amount of heat transfer from both the environment and user interaction by introducing two designs to the cooler. The first is a user-induced vacuum chamber, and the second is a suction-style silicone lid. Let's go over the vacuum chamber first. So a vacuum chamber is made of two steel plates with air in between them. When the air is removed, there are no molecules left for heat to move across. The result is an insulator capable of keeping liquid nitrogen at negative 321 degrees Fahrenheit for up to 1 week. Vacuum chambers aren't used in coolers right now because creating a permanent vacuum chamber at a 20-quart capacity would cost well above a $50 price point. However, using the power of science, we can create a temporary vacuum chamber that still provides excellent insulation at a lower price point. The user would connect a vacuum pump to the cooler when they would like to use it. A low-cost vacuum pump would cost around $8 and could even be powered by a car adapter. The valve you see is where the air would be sucked out of the cooler. This means that the user could create a vacuum seal that would provide superior insulation all throughout the day. Using this new technology opens up entirely new design concepts depending on the target price point. Since the vacuum chamber is made of two steel plates, there's no need for a plastic housing. The steel could be sprayed with a reflective coating to reduce the amount of infrared heat transfer, or it can be lined with a thin amount of silicone or other insulating plastic. The result is an eye-catching cooler that feels much sturdier in use and lasts significantly longer. The second piece of technology addresses the heat transfer introduced when the cooler is opened to grab a drink. So using a silicone lid allows us to create an airtight seal on top of the body. The hexagon you see is a simple push-push locking mechanism that creates downward force whenever it's locked into place. This ensures that the cooler is completely closed after use. So the design brings an excellent insulating method to the cooler size while reducing the traditional costs associated with it. The removal of plastics and foams makes the product environmentally friendly as it can be recycled after. So the result is a cooler that lasts much longer and performs much better than traditional offerings on the market, and the advances in vacuum technology introduced here helps a user create a product that is much cooler for longer amounts of time than traditional coolers. So I hope you enjoyed my design. Like I said, my name is Mandeep. I'm a mechanical engineer at the University of Texas, and I enjoyed the opportunity. Thank you.